Okay, so we left off here at conservation of momentum. Now, the big question is, how do we know that this is true? How can we figure this out? Um, and there is a great excerpt out of the Khan Academy uh, article, What is Conservation of Momentum, which I have also included an excerpt from that article in your homework. But it's all based off of Newton's third law. Remember that Newton's third law says that for every action, there's an equal and opposite reaction. Or if I apply a force to something, I'm going to get a force of equal magnitude applied towards me. That is exactly what this says, but in force A to B is just force B to A, but in the other direction. The time is going to be equal, which is pretty important, and this is where our impulse momentum theorem comes into play. Time that A is in contact with B is going to be the same time that B is in contact with A. So our time in both cases is going to be the same. So we can go ahead and say that our force times our time for A to B is going to be equal to our negative force from B to A times our time B to A. Notice that force times time is just impulse. So our impulse can also be written as our mass. Since mass isn't changing, our change in momentum is only going to come from our change in velocity. So we have mass A times our change in velocity A is going to be equal to negative mass B, but really the negative just applies to our velocity. Negative mass B times change in velocity of B. If I work out this problem and I get everything on the same side, I end up with this fancy equation: mass A times change in velocity A plus mass B times change in velocity B equals 0. So this is another way of representing our equation. There are two equations. The ones from back here, P1I plus P2I, so on, equals P1F plus P2F. That works, but also this equation is going to work. An important thing is that time during a collision is usually really short, so a lot of times we can just ignore external forces on our system, like friction. We can see this in pool when you have a cue ball that hits 7 or 6 or an 8 ball. The time of impact is very, very short, so it's usually negligible. So let's look at a few problems. I have a 500 kilogram cannon on wheels fires a 2 kilogram cannonball horizontally 200 meters per second. The question is, how much is the cannon going to roll backwards? How much is it going to recoil? Well, my momentum of my cannon plus the momentum of my cannonball is going to be equal to 0. That's from our second equation that we looked at. Or I can extend it to mc times vc plus mb times vb is going to end up equaling 0. 500 kilograms times velocity c, again, that's the one that I'm finding. I want to know how fast it's recoiling, plus 2 kilograms times 200 meters per second equals 0. I'm just going to solve this out. And if I get everything, I start moving things around. I multiply 2 times 200 to get 400, and I subtract it from the other side. I get 500 kilograms times my velocity equals negative 400 kilograms meters per second. I divide 500 on each side, and I end up with a velocity of negative 0.8 meters per second. So it's going backwards at 0.8 meters per second. Since it's so much more massive, it's not going to have as much of a change in velocity as the cannonball. If I plug this into the first equation, the P1I plus P2I equals P1F plus P2F, I end up getting the correct answer. Again, this just shows you can use either equation. So 500 times, they're both stationary, so 500 kilograms times 0 meters per second plus 2 kilograms times 0 meters per second, 0, equals 500 times negative 0.8 meters per second plus 2 times 200. All right, so I know that was a lot, but your homework assignment is as follows. There's going to be a momentum math sheet that you have to complete. It's going to have a lot of problems, kind of like what we just went over. And then assignment number 2 is going to be more of a writing assignment. You're going to consider different situations, and you're going to use what you learned about conservation of momentum to answer these questions. And there's a little more information on there. So good luck.